Hi class, welcome back. Today we're going to be going over lesson 6, which is talking about applications of cosine law, sine law, and ratios. So basically everything that we've kind of been learning up until this point, we're going to wrap it up really neatly into this word problems lesson. So remember when I told you that there's 4 different categories, thinking and inquiry, knowledge, and then application and communication. So what we've been focusing on mostly in class is largely knowledge questions. We've been going over how to solve problems, not really how to use them in the real world. So what we're going to be doing today is we're going to be talking about how to take information that we have in the real world and then take information that we have from our classes and then combine those two together to solve problems outside of just triangles that you find on a test in a class. So sine and cosine law can be used to solve various right angle triangles. And in this lesson, we'll be drawing on how to draw diagrams to solve word problems, as well as use cosine and sine law in order to solve word problems. We'll also be talking about how to use trig ratios. In this situation, we're actually going to be using cosine and sine law in conjunction with trig ratios. So it's just important to remember that when you're using cosine and sine law, you're only using them for triangles for which we do not have a right angle triangle, and then you're using trig ratios only in right angle triangles. Okay, so by the end of this period, I just wanted to write down what you will be doing for homework. Your homework questions will be the rest of your workbook pages, so I'm just going to write that in. Homework is the rest of your workbook pages, plus I've posted some worksheets. And those can be found on our learning environment. Okay, so as we move forward, I'm just going to start this off by saying what is expected by the end of this period or by the end of this lesson. You will know how to apply cosine and sine laws to various word problems. You'll be able to draw diagrams pertaining to word problems, and you'll be able to use trigonometric ratios, sine law, and cosine law in various settings. So you'll be able to use all 3 of the things that we've learned so far in order to solve word problems, okay? So let's just get started with example number 1. It says that Jillian is trying to calculate the height of a tree. She measures the angle of the elevation to the top of the tree from a certain point to be 15 degrees. Then, after she walks directly towards the tree, 31.4 feet, she realizes that the angle of elevation is 17 degrees. So as to calculate the height of the tree to the nearest foot. So first things first, let's draw out our diagram here. So I'm just going to draw out my tree, right? So my tree looks something like this. I'm just going to make it look a little bit better. So, and maybe I'll make it this forest green color. So that's my tree, and I'm sorry, I'm not an artist. Right, that's my tree. So she measures the angle from some point. We'll say that point over here, right? So some distance over here, right? And she notices that the angle of elevation to the top of this tree, so I'm just going to use a ruler because it's just nice and neat that way. So she notices that the angle of elevation to the top of this tree, and we know that that's the angle of elevation because it's opening upwards with the horizontal. So that angle right there is going to be about 15 degrees. So I'm just going to go write that in. 15 degrees. Right? And then she walks towards the tree. So she's moving in closer towards the tree, and she walks over here. And then she notices, so she walks about 31.4 feet. So we'll write 31.4 here. Right towards the tree, and now when she looks up at the tree, and I'll do this in a different color, now when she looks up at the tree, this angle of elevation is actually 17 degrees, right? So the angle of elevation is just a little bit different because she's walked now towards the tree. Okay, so it says to find the height of the tree. I don't have enough information here. I do know that this is a overall right angle triangle, but I don't know what this opposite is. I don't know what the height of the tree is. I don't know what the adjacent is. I don't really have much information other than I have this angle over here and I have this A over here. So I'm just going to go in and label this. I'm going to say, okay, this is A, B, C, and D. So if you look at this as two bigger triangles, it might be easier to solve, and as two smaller triangles. So let's try to solve the smaller triangle right here, triangle A, C, and D. So I'm just going to go in and highlight that triangle in orange, right? So if you notice it, it's right here. And naturally, I'm going to use a ruler because it'll make it a little bit easier for us to see the triangle. So it looks something like this, right? So I have this triangle over here, right? I only have one angle and I have one side. But what I can do is if I look at this triangle, I know that I know this angle right here. And I know that this is a straight line. So if I look at this and I say, okay, this is 17. If you remember from grade 9, if you have an angle on a straight line, that entire straight line is equal to 180 degrees. So I know that this angle over here is just going to be 180 minus 17 because when you add those two angles together, they need to equal 180. So I can find this angle right here, angle C, by saying 180 minus 17 is equal to angle C, which is going to be 163. I'm just going to go in here and say, okay, this angle right here is 163. Now that I know that angle here, I notice that I have two angles and one side, right? When you have two angles in one side, you can use sine law. So I'm going to use sine law, but in order to use sine law, I have side A. I need to find angle A. And in order to find angle A, I know that inside this entire orange triangle, all my angles need to add up to 180. So in order to find angle A, I know that angle A is going to be 180 minus 15 minus 163, which is going to give me 180 minus 15 minus 168 is going to be 2. So I know that angle A is 2 degrees. Now I have angle A and I have side A. I can find now side C and side D. So I'm just going to go ahead and find side C just because. So this is angle C, this is side C, right? It's the one that I did like the least amount of steps to get to. So it's just probably the most accurate. If you wanted to, you could also find side D and then use that smaller triangle in order to solve your problem. But I'm just going to use the overall bigger triangle to solve my problem and find that hypotenuse, right? So I'm going to use, just to clarify what triangle I'm going to use this one, right? The overall bigger one. But if you really wanted to, you could have used the smaller one. Either one would have given you the right answer. You just have to do a little bit more work using D. So I'm going to go over and I'm going to just highlight it again so that you can see what triangle I'm solving for, just the overall bigger one, right? So I'm trying to find C now, right? So let's go in and find C. So I know that I have angle A, which is going to be 2 degrees. I have side A, which is going to be 31.4 feet, 31.4. I know what angle C is. Angle C is 163. And I know that side C, I don't know what it is. So I have two angles in a side. So in this situation, I can actually use sine law because I have two angles. I have an angle and a side that are from the same letter. So I have angle A and I have side A. So let's do that. And I'm looking for a side, so I'm actually going to use my sine law here. Sine law to find side C. So I'm just going to say this is my given, right? And my required is side C. And you don't need to write the you don't need to write the grass method, and I'm just telling you what it is. So I know sine law is equal to A over, And you can look off of your sheet to find this. A over sine A is equal to C over sine Z, right? So let's just go put in the values that I know. I know A is equal to 31.4. I know sine, angle A is equal to 2, is equal to C, which I don't know, over sine, and angle C is equal to 136, right? And now I just want to get the C by itself, so I'm going to isolate. And to isolate, I want to get rid of the sine 163 at the bottom, so I'm going to multiply both sides by sine 163. Cross these two out, right? And I like to do the division first, so I like to do 31.4 divided by sine 2, and then I like to multiply, so I do sine 63. You could do sine 63 multiplied by 31.4 divided by sine 2. You'd get the same answer. And the answer here is going to be 801. Oops. It should be 200. Sorry, I'm just going to put that back in. So sine 31.4 divided by sine 2 multiplied by sine 163 is going to give me 263.1, right? So I know that side C is equal to 263.05, which I'm just going to round up to 1 meters, is equal to side C. So for clarity's sake, I always like to go back in and draw in where that is so that I can see it. 263.1. Right? And I'm just going to pull out the larger triangle now. So I found side C. I'm not done. I haven't found the height of my tree. But if I look at the bigger picture here, and I'm just going to put it in this purple marker. If I look at the bigger picture here, and I draw this purple triangle in, right, I'll notice that I have from angle 15, right, I have one angle in there. So from angle 15, I have the height, which is the opposite, and I have the hypotenuse. So in this situation, because if I just draw the same triangle out like this, I have 15, right? I have the height of the tree, and then I have C, which was 263.1, and I'm just saying that I'm bringing this out just so that we have it with all the without all the messiness, right? I can see now I have the opposite and I have the hypotenuse, so I know I can use sine here, right? So I know that sine 15, right? Because I'm looking at angle 15. Sorry, sine 15, and I'll just write in my equation first. Sine theta is equal to opposite over hypotenuse, right? So H is op, this is hyp, this is adjacent. So sine 15, because that's my theta value, is equal to the height over 263.1, right? In order to get what H is, I'm just going to isolate. So I'm going to multiply both sides by 263.1. So I'm left with 263.1 multiplied by sine 15, which should give me roughly about 68.1 meters is the height. So height is equal to 68.1 feet, sorry. So always write your therefore statement, therefore and I'm going to write it in the black marker, therefore the height of the tree is 68.1 meters. Right, and this is why that diagram is important to draw, and you need to know how to draw the diagram, because without the diagram you wouldn't be able to solve this problem. And it's important to realize that we used both sine law here. So we used sine law at first. We used that internal angle theorem, right? So we used the everything adds up to 180 degrees, right? And we also used the sine trig ratios, right? So we used trig ratios. So we're kind of just putting everything that we've learned so far in this course together to add up to answer and solve a problem. Okay? Alrighty. So if you would like, try, and if you're like, okay, I kind of get what she was doing, try and solve example 2 by yourself, because again, we're just putting two triangles together, right? Try and solve example 2 by yourself. If you still need a little bit of practice with this stuff, follow through my example on this one and then try example 3 by yourself. I've given you more than enough word problems to go through on your own. Okay? So it says, in this situation, I've actually given you the diagram already. So it says to measure the height of AB, right? So this is some inaccessible cliff. We don't know, we can't get there. This is the cliff. So I'm just going to label this as side C, right? Because it's opposite to angle C. And then it says to find the height of the cliff to the nearest meter. So it's important to recognize that we have two different triangles here. We have this one, which is actually a right angle triangle, right? So I'm just going to leave this here. Pardon my very poor drawing skills. I'm going to leave that here as the blue triangle, and then I'm going to make the other one in orange. So then if you go out here, this is the other triangle. This is not a right angle triangle, right? Because it doesn't have this box over here. So it means that it's not a right angle triangle. Okay? So for starters, let's just look at this as two separate triangles. Let's just try to solve what we can. Right now, I can't really do anything with this over here. I don't have any side lengths with the right angle triangle. I do have some type of angles, like I could possibly find angle A, but there's not really much I can do with it right now, so I'm just going to leave it. I'm going to move on to my orange triangle. I'm going to see, okay, in this situation, I have two angles and I have one side. So if I go back and I look at my rules for sine and cosine law, I know that for sine law, I can actually use this because I have two angles and one side. But first things first, I need to find something that has both an angle and a side. So an angle that has the corresponding opposite side. So if I look here at C, I look to the opposite, there's nothing here. Right? I look here at D, I look to the opposite side, there's nothing there. I look here at side B I have, but I don't have angle B. I can find angle B though, because I have two angles in this triangle already. So let's go find angle B first. Right? So let's find angle B. Right? So there's always some sort of method to solving these problems. So let's find angle B. So angle B is equal to just 180 because that's how much total degrees these angles need to add up to, minus 61.5 minus 49.3. And because I have 0.1 and 0.3, we're going to leave this as a point to one decimal place as well. So the angle is going to be 65.6 degrees. So that's going to be our angle over here. It's going to be 65.6 degrees is angle B. Now, I have angle B and I have side B. If I have a side and I have its corresponding angle, I can use sine law now. Right? So let's use sine law to find either angle or either side C or side D. If I look at this logically, I could find either one. I can find side C over here, or I can find side D. Side C is not part of that triangle that I'm looking for, right? But side D is. So I'm going to want to find side D because that's going to give me the adjacent, and then I can use my trig ratio to find the side C, which is, I'll also write this as the cliff height, right? So side X. I can find the height of the cliff using my ratio because I'll have the adjacent to that, to some sort of angle in that right angle triangle. So let's use sine law to find D. And if you went in here and you found C and D, that's not wrong. It just is an extra step that you didn't necessarily have to take. Okay, so B over sine B is equal to D over sine D, and that's just from your equation sheet for finding angles. So I know that B is equal to 185. Sine angle B, which is 65.6, is equal to D, which I don't know what it is, over sine D, which is 49.3. Right? I'm just going to get rid of this sine 49.3. So I'm going to say, okay, sine 49.3, multiply it on both sides just to cancel it on that one. So I crossed it out over here, and then I'm just going to do the math here. I'm going to do 185 divided by sine 65.6 multiplied by sine 49.3. And I just do it in one step so that I'm not carrying over too many decimals and having to type everything back into my calculator. So then in this situation, I got 154.01 is equal to D. And I like to keep as many decimal places as I possibly can, just because it makes it easier when you're solving you get just a more accurate number. So I keep 2 at least. If you want to keep more, that's even better. So I have 154.01 is that side. So I'm just going to go in and redraw that blue triangle I had here, right? So it's a 90-degree angle. I know this side is 154.01. This is the side I'm looking for, the side of the cliff, and I don't know what this is. And I know that this angle is 30.5. I just took the blue triangle out so that it was easier to work with. Now, I know that opposite to this is x, and I have the adjacent. So if I look at ka, toa, sine is opposite over hypotenuse. I don't have the hypotenuse, so I'm going to get rid of that. Ka is adjacent over hypotenuse. I have the adjacent, but I don't really care what the hypotenuse is. And then I have toa, which is tan is opposite over adjacent, so I'm going to use tan. So tan theta is equal opposite over adjacent, which I have, right? I have the op here. I have the adjacent here. So let's go in and put in our numbers. Tan 30.5 is equal to x, because we don't know what that is, over the adjacent, which is 154.01. I'm going to multiply it on both sides. So I'm left with tan 30.5 times 154.01, which is going to give us roughly 90.7. So that's going to be my x value, 90.7. And we said that it was meters, right? So I know, and I'm just going to write in my statement, therefore, and I like to write in meters here just so that I don't forget what the unit was. So 90.7 meters is the height of the cliff. The cliff is 90.7 meters tall. And that's my answer. So I just like to go back and highlight it. And the 3 dots just represent therefore. Okay. So this is another one where you're going to have to draw the diagram. So pause it here. Try doing this one by yourself. It is definitely worthwhile, and there's multiple ways to get to the same solution. So if you find yourself getting to the same solution and mathematically it makes sense, then like so be it. My job is to just show you the most efficient way to get to the same solution. Okay, so pause this video here, try working through it by yourself, and then we will take it up together. Alrighty, so hopefully you pause the video and you're just coming back now. So it says here, and I like to just go in and highlight all the important stuff. So it says the distress signal received from a ship 21 kilometers away from an eastern port. So I know that there's going to be a ship somewhere, so I'm going to write ship, right? And I know that there's going to be some sort of eastern port somewhere. So especially when we have stuff like eastern and western, I just like to go in and draw a compass for myself. So never eat shredded wheat. If you remember that, north, east, south, west. So I just draw the eastern port east naturally. So This is the eastern port, and we'll put that as EP, right? So I just like to go in and draw stuff in as I get it, the information. If you would like to read it first, that's fine too. Both are proper strategies to use. So this is 21 kilometers away from each other. The eastern port is 24 kilometers directly east of a western port. So this is east, right? Because it's going this way. So west would be the opposite direction. And it says directly, so I'm just going to draw a straight line from east to west. Right? So I have that. So I'm going to label this as WP, which is western port. And it says that it is 24 kilometers directly east. So that means that that distance is 24 kilometers. Right? What is the angle to the western shoreline that the ship should head to dock at the western port if it is 17 kilometers away? So that means that the ship is about 17 kilometers away from this western port. So I'm looking for, this is 17 kilometers. And this western shoreline, and I'm just going to draw it in this green, right? The western shoreline will look like this, right? It's just like that, like when you go to the beach, there's that shoreline. So that's the western shoreline. So I'm just going to write that. Western shoreline. So if this ship now is going to come this way, what angle does it want to come at? And that angle is going to be represented by this right here. Right, so this is the angle we're looking for. So I'm going to write this in as theta. So there's a few things that we need to do here first, right? The first thing you need to realize is that this is a right angle triangle. That's important to know for later. And the other thing you need to notice is that here, we don't actually have angles inside of this triangle, right? So we only have all three sides. And if you're given side, 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 we know that we need to use cosine law, right? So if you go back and you look at your cosine law problems, you'll notice that for cosine law, it'll actually tell you the angle. So I like to label this as A, B, C, just so that it's clear for me, right? And in order to find either angle A, B, C, right, you're going to use this equation. So I want to find angle B because ultimately I'm going to use it to solve for theta, right? Because I can find angle C and I can find angle A. They're just not useful for me. So let's find the one that we want to find, right? We want to find angle B. So I know that angle B, which is the angle at the western point right here. So we're looking for this angle right here, right? So angle B is going to be equal to side, and I'm just going to go in and label my sides as well. Side A squared plus side C squared minus side B squared. And this is just straight from your note. I just have them memorized, but that you don't have to. Is equal to, and this is going to be cosine, right? Cos B, right, over 2AC. So I'm just going to go in and put my values in. So I know that angle A, the opposite is going to be side A, which I know is 24, squared plus side C is going to be 17, squared minus side B is 21, squared divided by 2 times 24 times 17, right? And then, so cosine B is equal to 17 squared. I'm just going to put these into my calculator. 24 squared plus 17 squared minus 21 squared is all going to be 424 over 2 times 24 times 17. And now it's up to your discretion whether or not you would like to do 424 divided by 16, or you can just use the fraction and put that into the calculator, right? And you want to get rid of this cosine here, so whatever you need to do, you need to get rid of, do the opposite. So the opposite of cosine is inverse cosine. So you're going to do inverse cosine 424 8 over 816, right? So I like to just put it all in as a bracket. So I actually put in cos inverse 424 over, and I have that button on my calculator, so I just over 816. So I put it in as a fraction, and I get B, or angle B, is equal to 58.69. So I like to write 59. So I know that this angle right here is 59. And since this entire thing, right, this entire thing makes a right 90-degree triangle, or right 90-degree angle, now I know that in my 90-degree angle, one of the angles is 59. So it's really easy to find the other one. A 90-degree angle is always equal to 90 degrees. If I know that half of it is 59, or some portion of it is 59, I just have to do 90 minus 59 is equal to theta, right? So 90 minus 59 is 31. So I know that that angle is 31 degrees right here. Right? So the ship should head towards the dock, or the western port. So therefore, the ship should head 31 degrees to dock at the western port. Or the ship should head at an angle of 31 degrees, for better English. I'm just going to go highlight this, because I like to keep all mine highlighted, right? And then we're going to move on. So we're going to do example 4 and 5, and then we're just going to go over, these are actually from your textbook, from your notebook, and we're just going to go over some of these problems with you, which ones you should use, and just a summary sheet for you to have for yourself, and then we'll be done this lesson. All right, so try doing example 4 and 5 on your own, and then just come back and watch the solutions, okay? So pause the video, do both, and then I'll take both of them up. All right, so hopefully you listened and you paused the video. It says that a triangular plot of land between 3 roads. What angle will be made for the 2 rows at A? So, like always, first things first, go in and draw a diagram. I like to just label them A, B, and C because that corresponds with the equations that I have. And I want to find what is the angle that is made between 2 rows at A. So I want to find this, right? And then I have some other information. So the length of AB is going to be 4.7. So I'm going to write 4.7 here. The angle of B and C is going to be, so B and C is going to be 4.2, right? And then the angle of A and C, so from here to here, is going to be 6.9. 6.9. And I like to just go in and give myself labels, so I know this is side A, I know this is side C, and I know this is side B. And this just keeps my drawings clean. And it also helps me figure out what I need to use and what each of those values are when I have to go plug them in. So in this situation, I have side, 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 which means that I do need to use cosine law because I don't actually have any angles, right? And I know that cosine law is going to be, I want to find angle A, right? So cosine law to find angle A is going to be cosine A is equal to B squared. And again, you will have access to this on your test. You do not need to memorize this. A squared over 2BC. I've just used it enough that I have it memorized, but you don't need to, right? And I'm just going to go say, okay, what do I have? I don't know what A is because that's what I'm looking for. So cosine A is equal to B, which is at 6.9 squared, plus C, which is 4.7 squared, minus 4.2 squared, all over 2 times 6.9 times 4.7. And like I said, I think with cosine law, the biggest thing is always just plugging in and making sure that you're plugging in the right values. So just make sure you're cognizant of that. So if I do 6.9 squared plus 4.7 squared minus 4.2 squared, I just did it all in one step. It's going to equal 52.606, sorry. And then I did 2 times 6.9 times 4.7 at the bottom, which is going to give me 64.86. And that's all going to equal cosine A, right? And in order to get angle A on its own, I need to get rid of that cosine. And in order to get rid of cosine, we just know that we need to do inverse cos. So I like to go in and say, okay, inverse cos here. We'll cancel out the cosine, and whatever I do to one side, I have to do to the other. So I like to do inverse cos, and then I actually put in the fraction. So I say 42.06 over 64.86. And I know that my answer is going to be A is equal to 36.6, so it's going to be around 37. So angle A is about 37 degrees, so I'm going to put that in. So it says, what is the angle that's made? Therefore, the angle made at angle A is 37 degrees. And I like to just highlight it so that's there. Okay. All right. And now, last but not least, it says, Phineas and Ferb were measuring the height of a cloud directly above them. The results from the clinometer are given below, right? So it says Phineas and Ferb. I drew out this little diagram for us, so we don't need to draw it, right? But we have Phineas over here, which is labeled by P. We have Ferb over here, which is labeled by the F. And then we have our cloud up here, which I'm going to label as C because I want to have a value for that, right? And if I go in, I just want to go draw in my side C, which is right across from there, F and P. Right, and it's asking for the height of the cloud, so I'm just going to actually go in and write H here. I'm just going to divide this so that it looks, we know what we're looking for. Just because I'm dividing it does not mean that the angle 110 is divided by 2. Because the sides are different and it's not an isosceles triangle, we can't assume that we know what that angle is. Right, so we actually don't know what these two angles are. We just know that they both add up to 110. Okay, so now I have this. There's a few things that we can do here. There's actually 2 ways to solve this problem. I'll show you one way and then I'll show you the other way as well. So if I look at this and I look at the broader triangle, right, so I look at the larger triangle, I have here side C and angle C, right, because angle C is still equal to 110. And then I have angle F or angle P, but I don't have side F or side P. So I have 2 angles, right, and a corresponding side. So I can use sine law. So I'm going to find side P first, but you can find side F. It doesn't really matter which one you do. It just means that you'll be doing something slightly different. So I'll show you both ways. So I went in and I found side P. So I'm going to say, okay, in order to find side P, I'm going to use side C over sine C is equal to side P over sine P, right? Just using sine law. And since I know that C is equal to 350, I know that angle C is equal to 110. P, I don't know what that side is yet, so I'm going to just write it in like that. And then sine angle P is equal to 50, right? Now, in order to get this by itself, I'm just going to do sine 50, multiply both sides by sine 50. Right, this cancels out. So I'm left with 350 divided by sine 110. Right, multiplied by sine 50 is going to give me 285.2 0.32. So I'm just going to leave it as 0.32 is equal to side P. So I know the value of this side over here is 285.32. Now that I know that, I can use this little yellow triangle in order to solve for the height because it's a 90-degree angle, right? So let's just pull out this yellow triangle, and I'm going to just draw it over here in yellow, right? I don't know what the side length is. I can't assume that it's 350 divided by 2, but I know that this is 20, right? I know that this is 285.32, and I'm looking for the height. And in this situation, I have the opposite and I have the hypotenuse, so I can use the sine ratio. I can use trig ratio here. Sine. So I know sine is equal to theta is equal to opposite over, and I'm going to actually do it where I have a little bit more space. So I'm just going to drag this down here. So I know that sine theta is equal to opposite over hypotenuse, right? I know that my theta is sine 20 over the opposite, which is the height, over the hypotenuse, which is 285.32, multiplied by 285.32, multiplied by 285.32, right? So I'm just going to do that. 285.32 times sine 20 is going to give me 97.56, so I'm just going to leave it as 97.6 meters is the height. If you did it this way, that's awesome, right? If you did it another way, I'm going to show you the other way, because what you might have done is you might have, instead of finding side P, you might have found side F. Also correct. I'll just show you how to do that. But if you already did it this way, you can just skip over that explanation if you don't really care. Okay? So, what you could have done is instead of finding side P, which is what I did here, which is what I did here when I did the yellow one, you could have found side F. Right? And how you would have done that is by using the same thing. You would have used sine law, right? You would have used C. So you would have done, so I'm just going to write or. Right? So you could have done sine law, so you could have done C over sine C. This doesn't change. Equals F over sine F. Right? So you could have done 350 divided by sine 110 is equal to F over sine 20. Right? And now you just want to get the sine 20 out of your way. Multiply both sides by sine 20. Sorry, I'm just going to move this or. Right? And now I'm left with 350 divided by sine 10. 110. Multiply by sine 20, which is going to give me roughly 127.4. So I know that side F is equal to 127.4 meters, right? And I'm just going to go write that in here. And now I'm just going to pull out this blue triangle for you. So if I was going to pull out this blue triangle, right, I'd have this 90-degree angle here. I'd still be looking for height. I know that this would be 50, and then this would be C, and this would be P, right? From angle P, I have the height. I know that the hypotenuse is 127.4 because that's what I just found. I have the opposite. I have the hypotenuse, so I'm still going to use the sine ratio. It's just now my sine is going to be sine 50 is equal to height over 127.4. And even though the numbers are different, notice that you're going to get the same answer. So it's going to be multiplied by 127.4, 127.4, right? So times sine 50 is going to give me roughly 97.586, which is the same thing I got the first time, right? So 97.6 is going to be the height. Your decimals might be off slightly, so what I've been using is I've been using my answer key, right? So that ANS key at the bottom of your calculator. So I've just been using all the decimal places, but if you're not using all the decimal places, your answer might be slightly off, where it might be 97.7, but it's still close enough, okay? And so that's going to be your answer. So either way you do it, you're going to get the same answer, okay? That's just two different ways of approaching a problem. Same problem, different methods. And I'm not opposed to you using different methods to get to the same answer. I just want to see your thinking. Okay? So, like I said, knowing when to use trig ratios, knowing when to use sine law, and knowing when to use cosine law is super important. So I made a little bit of a reference sheet for you so that you can remember which one to use. Obviously, you can't have this on a test or a quiz, but it's a really great study material, and this is actually straight out of your workbook as well. So if you would like, you can actually go back into your workbook and fill out this part of the note. So it says, when do we use the following? So when do you use SOHCAHTOA or trig ratios? And so you use SOHCAHTOA when you're given a right angle triangle only. So your triangle needs to have a right angle in it somewhere, right? And you're given two of the following. Either you're given the opposite side of the angle. So let's just use this as an angle. You're given the opposite side, you're given the hypotenuse, or you're given the adjacent side, or you're given the angle itself and you're given either the adjacent, opposite, or hypotenuse. You just need two of the following in order to solve for the other one, okay? Sine law is used when you have non-right angle triangles, and this is the biggest difference. Any triangle that doesn't have a right angle in it, and if you have one of the following scenarios. So if you're given two angles in one side, so if you're given something like this, right, which is going to be, you're given x, you're given, so let's just write it in, actually. So I'm just going to draw in our angles here, right? So say you have 20, 60, right? You're given an angle, and then you're given the corresponding side, right? So you're given this side, and you're missing the rest, right? Or any side for that matter. If you're given two angles on any side, you can use that. If you're given side, angle, angle, right? So if you're given two angles and a side, right? You can use that. Or if you're given angle, right? So you're given angle, and then you're given the side, right? And then you're given another angle, right? Because you can always just find that third angle. Cool? Or if you're given two sides and one side that is opposite to the angle is given. So there should be two angles. Sorry about that. There should be two angles. So if you're given two angles and the opposite to that side is, that angle is given. So if you're given something like this, right, where I give you this triangle and I say, okay, you have angle A, B, C, and you have side B, which is also equal to, or side A, which is also equal to 25. And then you have, say, side B, which is equal to 60, right? If you have one where you have this two sides and some other side, you can do that. Or if you have this angle B and you don't have side B, you can use that as well. Okay? So that's a scenario where you can use those two. All right. Cosine law is basically when you can't use sine law, you have to use cosine law, right? You just don't have enough information to use sine law. You're not given an angle and its corresponding angle, or a side and its corresponding angle. So if you have two angles with a contained side, so if you have something like this, where you're given triangle ABC, and you're given this side, so you're given 40, you're given 50, right? And then you're given the angle here, which is 60, but you're not given A and C, right? So B doesn't have a corresponding value, nothing else. You can't find any of the other angles, so you have to use cosine law. Or if you're given all three sides, right? So if you're given a measure of all three sides, so you're given 40, 60, 50, right? And you're given no angles, then you have to use cosine law as well. All right, so let's just do a little bit of practice. We're not actually going to solve these. You can solve these on your own in your notebook, but we're just going to go through and see which method would we use. So in this situation, right, you're given a side and you're given its corresponding angle, and then you're given one angle here, right? You have two angles, one side, you can use sine law, right? If you go back and you look at this, and it says right here, if you're given two angles and one side, you can use sine law. Simple, easy peasy. Here, it's a right angle triangle, so you can use SOHCAHTOA. Because of the right angle, right? In this situation, you're given two sides, but you're given a contained angle, right? So this is actually SAS, right? Where you have angle A and side, you don't have angle A, you have side A, side C, and then you have angle B, but you don't have side C. So none of them have a corresponding angle and a side. So this needs to be cosine law, because you can't make that ratio for sine law. Okay, I'm just going to go fix my C. In this situation, you're given all sides, so it's side, side, side. And as soon as you're given all sides and no angles, you know that it's cosine law, which is pretty easy to recognize, right? In this situation, you're given a right angle triangle, so you know right off the bat that this is trig ratios because of the right angle, right? So you're going to use SOHCAHTOA here. In this situation, you're given an angle and the corresponding side with it, right? The opposite side, so you're going to use sine law. Right? So for the next couple ones, it's actually just to explain your reasoning. What better way to explain your reasoning than to actually just do the math? But you're going to see which way you're going to use. So what I'll do is that I will answer all of these questions, but what I would say is that just come back and look at the answer, right? Don't watch me do all of these and not try them by yourself. They're just really great practice problems. And then you also have like the answer. If you did something wrong, the solutions are there for you, right? So I would recommend watching me complete these and then just coming back and being like, okay, did I do it the same way Miss Singh did? Did they get the right answer? And that's the right way to go about doing this. Right, so first things first, we're going to do number one. I noticed that it's a non-right angle triangle, which rules out right away that it's not going to be a trig ratio. Right, so I have to either use cosine or sine law. Let's see what information I have. I have two angles, right, and I have one side, which means that now I can use sine law. So I'm going to use, so I know I have two angles plus one side, so I know I can use sine law. So to use sine law, I need to know an angle and its corresponding side. So here I have A, I don't know what side A is. Here I have angle C, I don't know what side C is. I have side B, but I don't know what angle B is. I can find angle B though, because I have two angles in here. So I can say, okay, all the angles in this triangle are going to add up to 180. So therefore, A plus B plus C must equal 180. Right, so I can just do my triangle, or my angle B is just going to be 180 minus angle A, which is 56, minus angle C, which is 43. So 180 minus 56 minus 43 is going to give me roughly 81. So I'm going to throw that in there. So I know that angle B is 81. Now I have an angle and its corresponding side, so I can use my ratios to solve. So I can say, okay, B over sine B. And I'm looking for side A, so I'm going to say A over sine A. And I'm just going to put in my values. So I know side B is going to be 38 centimeters. I know sine 81, because angle B is 81. Side A, which is going to be A, I don't know that. And I know that angle A is 56, right? So now I'm just going to isolate for A. So I'm going to multiply both sides by sine 56. Multiply by sine 56. Cancel these two out. I'm left with 38 divided by sine 81 multiplied by sine 56, which is going to give me a side length of 31.9 is A. If you want, you could even leave it at 32. I'm not really picky about that, so I'm just going to highlight it. I like to just go write it back in. 9 centimeters. Need to always use units. Moving on, we're going to do example number 2. So in this situation, I have two sides, right? One angle, but this one angle doesn't have the corresponding side. So in this situation, I need to use cosine law, right? Because this is SAS, I need to use cosine law. So in cosine law, I know that I'm looking for side A, so I'm just going to go back and look at my equation. It's A squared plus B squared plus, A squared equals B squared plus C squared minus 2BC cos A, right? And I'm just going to go put in my values. So I know B is 14, I know C is 22. Right, I like to label my triangle. It just makes it easier for me to work with. So I know A squared is equal to 14 squared plus 22. And I like to always make sure everything's in brackets. That's just good form. Minus 2 times 14 times 22 cosine. And angle A is equal to 80, right? And so I'm going to just go put 14 squared plus 22 squared minus 2 times 14 times 22 times cos 22 all in one line in my calculator because it's just the most efficient way to do this, right? So I'm going to get, 14 squared plus 22 squared minus 2 times 14 times 22 times cos 80 is going to be 573.03. So A squared is equal to 573.03. And I like to write as many as I can. So 27226. And in order to get the A by itself, I have to square root both sides. So I'm left with A is equal to 23.9, so I'll leave it at 23.9. You could also write this as 23 or 24 if you would like, but I know 23.9 meters is the answer. And I like to just go throw it back in here. Equals 23.9. Okay. So moving on here, I'm looking for angle A. I have the corresponding side, and here I actually don't have C and I don't have angle B. So I only have two sides and actually I don't have any angles. I have no angles. I have only sides, right? Side, side, side. That means automatically I know I need to use cosine law, right? So I have S, therefore cosine law. And you don't need to write this. I'm writing it for the sake of clarity, right? And I'm looking for angle A, so I'm just going to go back to my cosine law. And the formula for cosine law for A is going to be cos A is equal to plus B squared plus C squared minus A squared all over 2BC. right? And I just have my formula sheet sitting in front of me so that I have access to it at all times. And that's probably the best thing to do. So I'm just going to go in and label my sides. C, oops, sorry, this is A. C, right? And that's why it's so important to label your sides properly. So cosine A is equal to B squared, which is 23, plus C squared, which is 33, minus 28 squared, divided by 2 times 23 times 33. And so if I do this right, I'm just going to plug in 23 squared plus 33 squared minus 28 squared into my calculator, and I get 834. And then I do 2 times 23 times 33, which is going to give me 1518, right? And then I want to get rid of this cosine over here. So whenever I'm looking for an angle, I have to do cos inverse because I want to get rid of the cos. And whatever I do to one side, I have to do to the other. So I'm going to do cos inverse, and I like to just put in the fraction by itself, and I'm left with angle A is equal to 57 degrees. Moving onwards, I have triangle ABC here, right? And I'm looking forward to, okay, what do I need to find? And it says that I need to find angle A again. In this situation, I actually have angle A and side C, angle C and side C. So because I have two corresponding angle and a side, I can actually use sine law here. Okay, so I'm going to say, okay, sine law. And I'm going to say, okay, so sine, and because I'm looking for an angle, I'm going to use this equation, sine C. And they're the same thing, honestly. If you switched it around, you would just have to do an extra step, and that's fine too. Sine A over side A. So I'm just going to go plug in what I know. So I know this is side A, this is side C, right? So sine 53 over 37 is equal to sine, and I don't know what angle A is, so I'm going to leave it, over 26. Right, I'm going to multiply by 26 to get rid of that 26 on both sides. And I'm just going to do, okay, sine 53 divided by 37 multiplied by 26 is going to give me 0.56120, so 0. And I like to just write in as many of the decimals as I can. And in order to get that A by itself, I have to do sine inverse. And whatever I do to one side, I have to do to the other. So I'm going to say sine inverse of this number, right? And I just like to use the A and S button on my calculator. It just makes it easier. I don't have to retype that entire number in. So I get 34.1. So I'm going to leave it as 34 equals A. So I found angle A using sine law. These ones, dead giveaway is that they're both right angle triangles. Sorry, this right angle should be there. So then we're just going to go down. I know I can use, for both of these, I can use SOHCAHTOA. Right, because they're both right angle triangles. Right? So I'm just going to go in here and be like, all right, I want to find out what side C is. I know that's the hypotenuse, right? I know that angle B is going to be 23, so I'm really sorry, but this is just messy, so I'm just going to go fix it for us. So this should be 23 over here, right? So if I look at angle B, I have the opposite of 23 over here, and then I have the hypotenuse. So if I go back and look at SOHCAHTOA, opposite over hypotenuse is the sine ratio. So I'm just going to use sine. So I'm going to say, okay, sine 23 is equal to 123 over C, because I don't know what C is right now, right? And then I'm just going to cross multiply. So I like to put this over 1. So I have 1 times 123, which is just 123, equals sine 23 times c. Then I'm going to divide both sides by sine 23. Divide by sine 23. I'm going to say, okay, so 123 divided by sine 23 is going to give me 314, right? So then I know my answer here is C is equal to 314.79. So I'm going to actually round it up to 315, right? And that's my answer. And then same thing here. It's a right angle triangle because I have that square over there. I know that I'm looking for angle B. So in this situation, I have the opposite and I actually have the adjacent, right? So I know that I can use my tan ratio over here. So I'm just going to say we're using tan for this one. So I know that tan theta, which I don't know what B is. So we'll say tan B is equal to opposite over adjacent. So I want to get rid of the tan, and because I'm looking for an angle, naturally I'm going to have to do tan inverse on both sides, right? So tan inverse. So tan inverse, and I like to just put in the like the fraction, so I just do 125 divided by 45, or over 45, right? And so then my angle B is equal to 70.2, so I'm just going to rate it as 70. Okay? And so if you could just go back in, and these are your workbook problems, so you can go in and look at those. And as you're watching this, if you have started doing your workbook problems already, let me know if you have any questions, and we can go over those in class as well. Thank you. Have a great day.